Okay, so 3.21 and 3.2 are about, or I'm sorry, this is 3.2 and 3.3. That's what it needs to be titled. They cover slope. And so they cover slope in two different ways, but I like covering it together. 3.2 really kind of just introduces slope. I believe 3.3 introduces the slope intercept form of a line, and I think it needs to go smushed together. So first off, let's talk about slope. Hopefully this isn't a word you've never heard. If so, that's fine. It really just means the slant of a line. It's a numerical way of identifying the slant of a line. So we use the letter M to notate it, and it's just rise over run. So I'm going to do a basic example first where there's no real formula. So if I wanted to find the slope of a line, let's say I've got, my X and Y axis from yesterday, from the last lecture, I guess. And I know 2 points on this line. Let's say I know that this line goes through -2, -1, and it also goes through 3, +1. Okay, so we've got -2, -1, and we also have 3, +1. And our line just shoots through there. We use a different color for the line. How about that? Make it more interesting. So to find the slope without doing the formula, which we'll hit the formula here in a minute, but if I wanted to find the slope here, all I have to do is stair step my way I always go from the left point to the right point. It makes it where the denominator is positive. So I always go from left to right. So if I want to go from this coordinate to this coordinate, we're going to rise and then run, right? We're going to go up and then over. Now, if we go down and over, we'd make that rise negative. We'll do an example like that here in a minute. But so if I want to go from here to here, I can go up, or I need to go up 1, 2 units, right? 2 units up. So, it's at -1 here. So 0, +1. And then I need to run 1, 2, 3, 4, 5 units. 5 units over. So that's my rise and my run. So the slope for this green line is going to be rise 2, we went up 2, and then over 5. Okay, rise 2, and then run 5. Kind of neat. Okay, where let's do another one that isn't positive. Let's do a negative slope. So let's say we have a line, and this one is going to go down. So let's say it goes through 1, 3 here. And then it goes through, let's say, 2, -1. Okay, so you've got 1, 3, right? You go up 1 over 3, and then you've got over 2 down 1. So 2, -1. And we connect the line, or connect the dots. So we know that this line goes through these 2 dots. Right? And if I wanted to do the same thing, actually, if I want to find the slope without using the equation of the line, again, I'm going to start at the leftmost dot. But the difference here is instead of going up and over, I'm going to go down and over, right? So I've got to go down 1, 2, 3, 4 units. Excuse me. So it's going to be 4 down. And then I only have to run 1 unit, right? Because we go from +1 to +2. So I've only got to run, I guess I can write it down here. I've only got to go 1 unit over from here to here. So my slope then, go back to my brown marker. I don't think you can really tell on the screen. But my slope here, since the rise is down 4, I'm going to use a negative. So it's -4. My run is a +1. So it's negative. It actually is -4 divided by 1. So that's just -4. Now look, I typically leave slope as a fraction, even though it does simplify to -4. If I can leave it as a fraction, I'm going to leave it as a fraction because it tells me the rise and the run if you leave it in fraction form, even if it simplifies. Okay. And notice this -4 is a steep slope, right? 2/5, which is like 0.4. It's a small number, right? 0.4. It's not as steep. It's not as steep of an incline. Like a +4 is going to look like this. 0.4 is going to look like that. okay? And then same thing over here, just down, okay? Questions about that? I've got two more slopes I need to hit before, and then then we'll get into the more formula stuff. Okay, so what about flat lines? I say flat lines. What if there's no, there's no up or down slant? So let's look at another one. Actually, let's introduce the formula first. I'll come back to the flat lines. That's not a big deal. I like introducing them with the formula. So let's look at a formula. Well, how do I find the slope if I just gave you two coordinates? How would I find the slope? Well, it turns out the rise is just the change in the y's. Now, a way to notate change is delta in mathematics. That means change. So change in the y's over change in the x's, okay? Change in the y's. So like if you see delta in any kind of math terminology, it just means change. And the way we actually find change is through subtraction. So if we've got two coordinates, let's say we've got two coordinates, x1, y1, and we've got x2, y2. So we've got two coordinates out there, and we want to find the slope. What we can do is actually subtract the y's and then subtract the x's. We have to be careful because whatever coordinate is first has to come first, and whatever coordinate second has to come second. It doesn't matter which one is x1, y1 or x2, y2 per se, but if you start with y2 up here, you have to start with x2 down here, okay? And you'll wind up with the same answer. So let's check this. Let's test it actually. Let's test it on this one. So if I want to find the slope for this line with the equation now, and I know two coordinates, it should get the same. We should get the same thing, right? I know two coordinates. We should wind up with 2/5. Let's see if that's true. So here's how I would do this. I'll do it down here. I know two coordinates are -2, -1, and 3, 1. And you'll see the homework at the beginning, I believe, of this homework looks like this, where they just give you two coordinates. It's something like, I'll make sure I'm not totally up on that. Yeah, they just give you two coordinates and they ask you to find the slope. It says, find the slope of the line containing each pair of coordinates. So let's say I gave you two coordinates. I said, hey, find the slope of the line that goes through these two points. Well, we can use this equation. Now, before I use it, I'm going to label which one is x1, y1, and x2, y2, okay? And then I'm just going to pop it in this formula. So slope is going to equal, I'm going to start with y2. So 1 minus, it's always minus because it's the change, right? 1 minus a -1, that's y2 minus y1, divided by x2 minus -2. So x2 minus a 3 minus a -2. Now we know two negatives only in mathematics make a positive, right? So this winds up being 1 plus 1 on top and 3 plus 2 on bottom. So I wind up with 2/5. Hey, same exact thing as we got over here. Now you don't have to do this both ways. If I should find the slope, just find the slope. But here's the formulaic way of finding the slope compared to the visual way of doing it, okay? Kind of the graphic way of doing it compared to the equational way, okay? So let's look at another example. Let's just kind of do some of these so we get comfortable with it. Just where I give you two coordinates and ask you to find the slope. So let's say we had, oh man, this pen's bleeding. Let's say we had M, or not M. Let's say our line goes through 4, -2, and 6, +5. I want you to find the slope. So find it for this one. Use the equation. If you want to go back, I mean, use the little equation there, and I want you to find the slope for these next few on your own. So let's do another one. -2, 1, and let's do -2, say 6. Okay. And then 3, 4, and 0, 4. Okay, try those three. Find the slope for each of those. I'll give you a few minutes to get that done. If you're watching on later, later in the day or whatnot, you can hit pause if you want. I'll give you just a few minutes. Okay, if you're working, that's fine. I'm going to kind of just follow up behind you. So let's see. We've got m equals. Now I'm going to say this is x1, y1, x2, y2. So 5 minus a negative 2 over 6 minus 4. So this is 5 plus 2, right? So then we wind up with 7 over 2. Now I'm going to leave it like this. Do not tell me this is like, this is called an improper fraction, right? But it's simplified. We can't simplify any further. Don't tell me this is like, what, 6 1/2? No, don't want that garbage, okay? I want improper fractions. So 7 over 2. Okay, the next one. Now I'm going to tell you the next one. Should have got a weird answer, okay? These two x values don't change. You know what? Before I even do this, I'm going to graph this line that contains these 2 points. I'm going to graph this line that contains these 2 points. So we've got the first point's negative 2, 1, right? The next point's negative 2, 6. 1. So negative 2, and we go up 6. 1, 2, 3, 4, 5, 6. Somewhere up there. Oh, hey, we have a line that we talked about yesterday for just a hot minute, right? This is a vertical line. And we know vertical lines. Remember, it was like x equals a number was a vertical line. But the slopes turn out to be different for vertical lines. So if we do the math here, this is x1, y1. This is x2, y2. We wind up with 6 minus 1 over negative 2 minus a negative 2. So we get, 5 on top. But then on the bottom, negative to negative make this a positive. There's no change in the x's. Remember, the denominator was delta x. It's the change in x. Well, there's no change. You wind up with 5 divided by 0, okay? And look, we can't divide anything by 0. It doesn't really make sense. It's like saying, I don't know. It's really just hard to explain. Actually, I can explain it if we had if it was like 0 divided by 5, it was the opposite. It would be like saying we have no money and we're going to divide it into our, 5 children for inheritance. Well, they all just get no money, right? But this one is like saying we've got $5 and we've got to divide it between 0 people. And it just doesn't make sense. It doesn't make sense so much that when you divide by 0 in mathematics, if the 0 is ever on the bottom, it's the bottom, it's going to be called undefined. We don't know how to deal with it. There's really 2 major glitches in algebra, and this is one of them. Okay, one of the glitches is dividing by 0. We just don't know how to do it. So it turns out we just say it's undefined. Now listen, what that means is all vertical lines, because there's no change in the x value down here, all vertical lines are going to have an undefined slope, right? All vertical lines. And I remember we know a little bit about these vertical lines already. From yesterday, they were x equals a number, okay? Well, it turns out also the slope is always undefined, okay? The slope of these vertical lines turns out to be always undefined. Okay, so this next one, the y's don't change. So I bet we have a horizontal line. Let's see. So if I graph this one, just to show you. We've got 1, 2, 3, 4. 1, 2, 3, 4. Okay, so the first coordinate, 3, 4. So we go over 3 and then up 4. And the second coordinate, 0, 4. Hey, that's our y-intercept, right? Because it's crossing the y-axis. And if we draw this line, you'll see it's a nice flat line. This is a horizontal line, right? Nice horizontal line. A nice horizontal line. So let's find the slope here. So m equals, I'll call this one x1, y1, x2, y2. And I get 4 minus 4 over 0 minus 3, right? So I wind up with, let's see here, wind up with 0 over negative 3. Now look, the 0 can be in the numerator. That's not a big deal. Again, that's like saying I have no money and I've got to divide it between so many people. Well, they all just get no money, right? So 0 divided by anything is just 0, okay? Which kind of makes sense. Remember, the slope is supposed to tell us the slant of the line or the change in the line. Look, this line is not changing, right? It's not going up and it's not going down. So therefore, it's just flat. I mean, it's flatlined. So therefore, the slope is just going to be 0. So it turns out this is true for all horizontal lines. Remember, horizontal lines were always y equals a number, from the last section, and the slope is always going to be 0. Okay, the slope always going to be 0. And I'll tell you, the author of this book, Dr. Martin Gay, I know I mentioned her a few times. She is all about these vertical and horizontal lines, and they'll come back in college algebra. It's not a big deal, but it feels like a curveball thing, like, oh, I'm finally getting this, and then you throw vertical and horizontal lines in there, and it doesn't feel the same. And it's because, remember, they're just x or y values, and their slopes are different. They're kind of goofy. Okay, make sure I'm on the right track here. Yes. Yes. Okay. So the next thing we're going to talk about is slope-intercept form, which is probably the most like if I ask students like, hey, tell me what you remember about slopes, someone yells out y equals mx plus b. It happens every single time, and that's fine. But this is slope-intercept form, and it's y equals mx plus b. Okay, y equals mx plus b. Now, what's nice about y equals mx plus b is we can graph a line directly out of it. So if a line is in this equation, we can graph it right out of the equation. We'll do that here in just 2 seconds. But we need to go over this equation first. So firstly, that m right there is our slope, right? It tells us the rise over run. And that b is actually our y-intercept. That b is our y-intercept. So the y-intercept tells us where to start, and the slope tells us where to go. Okay, the slope tells us, how much I rise and how much I run, right? Or how much I rise down and how much I run. Okay, so the y-intercept tells us where to start. The slope tells us where to go. So before we get there, we just need to pull information out of this slope-intercept form so we can use it. And let's look at an example. Let's say I've got a y equals 1/2 x plus 7. And I'm going to ask you, what's the slope? And what's the y-intercept? This is an easy one, right? Look, the slope is always the coefficient in front of the x. So it's always just going to be that 1/2. Okay, 1/2 is going to be our slope. The y-intercept, now look, I'm a stickler about this. The y-intercept is a coordinate. And remember from 3.1, if we're going to write a coordinate for the y-intercept, the x value is always 0. And the y value is actually whatever that b is. Okay, so the y-intercept turns out to be 0, 7. Pretty cool. Okay, pretty neat. Now, let's look at another one that's in a different form. Let's say it's in that form that we looked at yesterday. Let's say we've got 2x plus, say, 3y equals 12. Okay, 2x, I'm running out of room here. 2x plus 3y equals 12. And I'm going to ask you the same thing. Actually, you know what? I'm going to bring it up over here so I've got a little more room. I want you to find the slope and the y-intercept. Okay, slope and the y-intercept for this b value. Now look, we've got to get this form. This is called a standard form actually of a line. We've got to get it into this y-intercept. So all that means is we have to solve for y. Okay, if we can solve for y, we can get it into this slope-intercept form. So I'm going to do that. So first thing, I'm going to subtract 2x, and I get 3y equals negative 2x plus 12, right? That gets the y by itself, or the y, values, I should say, by itself. And then I've got to get the 3 to go away. Well, we know if we want to get the 3 to go away here, since it's being multiplied, we just divide everything by 3. Right now, I'm going to write this up here. So I wind up with y equals, now negative 2/3 x plus, well, 12 divided by 3 is just 4. Okay, 12 divided by 3 is just 4. So therefore, the slope for this one is going to be negative 2/3. And the y-intercept, remember, is 0, 4. Okay? It's 0, 4. And now we're going to go on. We're going to use this. Are there any questions about this before I go on, or questions about the last, finding the slope? I'll kind of pause here for a minute. I got to get some water. You can put them in the chat. You can jump in. It's not a big deal. I got to bring the chat up, actually. There we go. Okay. Okay, good. So now let's use this now to graph. Okay, and this is where I kind of go into 3.3. I feel she should have introduced it here, so that's what we're going to do. It just makes the most sense. So let's say I give you the same kind of thing. Let's say I've got hold on. Let me just steal one. Nah, I'm stealing one. So let's say I've got 2x plus, let's say 4y equals 8. 2x plus 4y equals 8. Now, here's what I want you to do. I want you to find, for part A, find the slope. So, and B, I want you to find the y-intercept. We're going to do this one together, actually. And then for part C, I want you to graph it. Okay, so remember, if we're going to find the slope and the y-intercept, we've got to get this in slope-intercept form. We've got to solve for y here, right? So to do that, I'm going to subtract the 2x over, and I'd have 4y. I'd have 4y equals negative 2x plus 8, right? I've got to subtract the 2x over. And then I'm going to divide everything by 4. I get y equals, now, negative 2 divided by 4, that's negative 1/2. I'm going to leave it as negative 1/2. So negative 1/2 x plus 2, okay? So I divided everything by 4, and I get 2 divided by 4, that's just 1/2. Now, look, I'll tell you with slope, I always put the negative in the numerator. And you'll see when we graph this why I do that. But I've got the slope and y-intercept here. My slope is going to be negative 1 over 2. Okay. And if it's negative, I put it in the numerator. And my y-intercept here is going to be 0, 2. So I can graph this thing. So I've got to start at 0, 2. Remember, you start at the y-intercept if you're going to graph this. So I'm going to start at 0, 2. I'm going to start right there. I know that my line goes through this coordinate because it's the line's y-intercept, right? So my line goes through that coordinate. Now, I don't know, I mean, I do know because we know the slope, but I don't know another coordinate per se on here, but I do know the slope. The slope is negative 1 over 2. So what that means is from that coordinate, I'm going to do the rise and the run. Remember, this is our rise, and this is our run, right? So I'm going to rise negative 1. So from here, I'm going to go down 1, and then I'm going to run 2, 1, 2. And I know I've got another coordinate on my graph, okay? And I can keep doing that if I want because we're only dealing with straight lines. So if I start here, I can go down 1 and then over 2, about right there. And I've got another coordinate. And I can go the opposite way too. I can go vice versa if I wanted to. Down 1 over 2, well, that's the same as going up 1 to the left 2. Boom, I've got another line, or another coordinate. Check this out. I found my line. There's my line. Okay, that's my graph of my line. So we found that from this equation, but instead of, remember yesterday, in the last section, we used a table, right, to find this line. Well, today we're using the slope intercept form to find the line. Okay, so yesterday we used making a chart, which works for any type of line. Okay, it could be curvy, doesn't matter, curvy, goofy, whatever, doesn't matter. But with straight lines, you can use slope intercept form. And since that's what we're talking about in chapter 3, we can utilize this form to graph the line. Okay, so let's I mean, if you got a question to ask me, that's fine. But let's do another one, and this one's going to be kind of set up for us already, but it looks a little different, okay? So let's say I give you the equation y equals 2x, okay? Y equals 2x. And again, I want you to tell me the slope. I want you to tell me the y-intercept. And then we're going to graph this one as well, okay? So, okay, now what's different about this one is it doesn't look like it has a y-intercept, right? If we want to get it in this form, you know, the y equals mx plus b form, right? Y equals mx plus b. We've got the m and the x, right? The slope is going to be just 2, but there's no y value. So what actually, there is a y value there. It's just 0, okay? And if you want to write plus 0 out here, you're more than welcome to kind of keep you there, keep you and to see what's going on, keep you on track. So what that means, now the slope is what's in front of the x-axis. Now that's 2. Now I need to think of this as rise over run though. So it is 2, that is the slope. But I need a rise and run. I need to write 2 as a fraction. And we can write any integer as a fraction by just putting 1 over it. So that's going to be my rise. And that's going to be my run, okay? So if you get just an integer and not a fraction like we did over here, you can think of it as the integer, whatever it is, divided by 1, right? Because anything divided by 1 is itself. Now the y-intercept, though, because it's not written, there's nothing over here, it's going to be the origin, 0, 0. So if I wanted to graph this one, I'm going to start at the origin for this one because that's where the y-intercept is. So for this one, I'm going to start at the origin. Unlike over here, right? Over here, if I had the y-intercept, it was 2. I have to start at 2. Well, here the y-intercept's the origin. So you always start at the origin. And now I'm going to rise 2 and run 1. I go up 2 and over 1. And I've got another coordinate on my line. Now I'll do that again, up 2, over 1. I've got another coordinate on the line, and boom. There's my line, okay? Y equals 2x. Okay, those are 2 really good examples. Let me know, but jump in here if you've got a question. I'm going to assume you don't, if you're not asking me anything. See here. I'm going to steal one from some homework from the book just so you kind of know what it kind of looks like. This is on page 195. So we're still in section 3.2. And the question, let's do question number let's say question 26. So we'll do an even one. Now this one doesn't ask you to graph it because really they make that a 3.3 topic, but I'm going to do that as well. 26 says negative 5x plus y equals 10. So it says find the slope and the y-intercept of each line, and I'm asking you to, I'm going to graph it as well, which kind of ties into 3.3. So we need to find the slope and the y-intercept of this line. Now remember, this is not in slope-intercept form. What would be nice is we can get it in slope-intercept form in one step. We just have to move the 5x over. So I'm going to add 5x to both sides. And I get y equals 5x plus 10, right? And now, boom, we got it. There's nothing in front of the y. So this is my slope-intercept form. So I actually know the slope here. You know, it's whatever's in front of x. It's just 5. Now I'm going to think of it as 5 over 1 when I'm graphing. And then my y-intercept is 0, 10, right? It's going to be 0, 10 because it's the constant out there by itself. Okay, let's graph this one. Now look, we're going to have to start up at 5, and then we go up 5 and over 1. So I'm going to start kind of really high on the graph. We'll go by 10s. How about that? We're going to go 5, 10, 15, 20. So So 5, 10, 15, 20. This is going to be a very steep slope, right? It's a slope of 5. I mean, that means for every 5 units up, we're only going to run 1 unit. So it's going to be a very steep line. There's 5, 10. So my y-intercept is at 10, right? And then I'm going to go, now think of this, remember it's 5 over 1. So I'm going to rise 5. So from 10, I'm going to go to 15, but then I'm going to go over 1. So I mean, I'm barely over there, right? My line looks something like that, very steep. Okay, very steep. Pretty cool. That's a good example. Okay, a good example. Okay, so no, let's do one that looks a little weirder, like 32. Just tells us y equals, still page 195, y equals negative 3.6. Okay, whoa, 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 whoa. Y equals negative 3.6. First off, it doesn't even have an x value, right? There's no x. We need an x for y equals mx plus b. This just has a constant. Okay, wait a minute. That means I need to turn my brain off autopilot here for a minute, because this is not the same type of line as this one. Okay, this is just y equals a number. Oh, wait a minute. We talked about this yesterday. If y equals a number, there's no x value going on, right? This y equals a number was a horizontal line. Horizontal line, okay? So now that makes this a little different. I'm going to go ahead and graph this to begin with, and then we'll talk about the slope and the y-intercept, just because I want a few more, I want an example of this actually. So y equals negative 3x. Now remember, this is our x-axis, and this is our y-axis. We're stuck at negative 3.6 on the y-axis. 1, 2, 3, 4. We're stuck. We'll use green again. We're stuck right here. That's about negative 3.6, right? And we can't go up or down from there. Okay, we're just stuck. That's what this line looks like. Y equals negative. Look, it's y, not x. X is going to be a vertical line. X would be stuck over here at negative 3.6 if it was an x value. Okay, but it's horizontal. Now remember, a few pages ago, we talked about horizontal lines and their slope. What was it? So m equals 0, right? M equals 0. If the slope is horizontal, it's not slanted up, it's not slanted down, it's just flat. It has a slope of 0. Now this one does have a y-intercept, right? It does go through 0, negative 3.6, right? Remember, this has to find the slope and the y-intercept. Okay, and we did, and for this one we graphed it. Okay. Man, thrilling. I know, super thrilling. Okay, so let's switch this one up a little bit, and let's do now one with an x. So I'm going to steal one from the book again. This is number 30. X equals 7.2. And again, wait a minute, there's not even a y value to solve for, right? We can't get, there's no way we could put this in y equals mx plus b. There's no y. So again, I'm going to graph it first, and then I'm going to pull what we know out of it. Okay, x equals 7.2. That means we're stuck on the x-axis at 7.2. So 1, 2, 3, 4, 5, 6, 7. Oh, crap. I mean, it's about right here. We're just stuck at x equals 7.2, right? We have a nice vertical line. Okay, a nice vertical line at x equals 7.2. Now, remember, vertical lines always have an undefined slope. We talked about that at kind of the beginning of this lecture. Since it's a vertical line, it's x equals a number, it's a vertical line. That means it's got an undefined slope. Now remember, what about the y-intercept here? Look, here's our y-axis, and here's our line. They run parallel, right? They're never going to touch each other. So it turns out if you've got a vertical line, unless it is just right here on the y-axis, if you've got a vertical line, it's never going to have a y-intercept. Your book uses the word no y-intercept as the solution. No y-intercept. Okay, no y-intercept. So this vertical line over here will never cross this line there. Therefore, this does not have a y-intercept. Doesn't have a y-intercept. Okay. Questions, comments, concerns? Okay, great. Let's kind of go backwards now. I'm going to give you a line, and I'm going to ask you to find y equals mx plus b. So this is kind of a change here. This is a good thinker question. I like it. Okay, let's say our line goes through -3 here, and it goes through +2 here. So it goes through -3, and then it goes through +2. So the y-intercept's -3, the x-intercept is +2. And I want you to find y equals mx plus b. Okay, look, we're not going to find, we'll learn ways to find y equals mx plus b with like equations and stuff here tomorrow actually. But for now, I want you to find it just from the graph. And we know one part really quickly from the graph. We know b, right? B from the graph is just where we cross the y-intercept, right? It's where our line crosses the y-axis. So the b value here has to be -3, right? It has to be -3. The slope, though, we're going to have to get with that rise over run. And again, I'm not going to use the equation, the subtracting the y's and subtracting the x's. I'm going to just start here, and I'm going to go up 1, 2, 3. So that means I rise 3. It's me here, and then I run 2. So therefore, my slope has to be rise 3, run 2. It's got to be 3/2. Okay. Now, I can find y equals mx plus b. I know the two parts, the b and the m. So y equals 3/2 x minus 3. Right? 3/2 is the slope, so it goes in front of the x. And then my y-intercept, -3, goes out here as a constant. That's my equation to this line. Kind of neat. We were just given a line, and we found the y-intercept visually from it. Pretty cool. Okay, we can't do that with all lines. It's hard whenever, say we had a y-intercept that was a decimal, right? It would be hard to see, where it actually crosses the y-axis. But if it's not, if you can see where it crosses the y-axis and you know another coordinate, you can just use this method to find the y-intercept of the line, or to find the slope-intercept form of the line. Pretty neat. Okay. Pretty cool. Any questions? Got to hit the last objective. There might be one other thing here. But now we're going to talk about parallel and perpendicular lines. Okay. Parallel and perpendicular. Let's see how they're brought up first. Yeah. Okay. So first, let's talk about parallel lines. Parallel lines. It turns out, we kind of talked about the parallel lines a second ago with that vertical line and the y-axis. But parallel lines never touch, right? So if we wanted to graph two parallel lines, they look something like this, right? I know that's not perfect because it's just by hand, but it would look something like this. They would just never touch. They go on and on forever. Now, for the purposes of what we're doing in this section, remember it's about slope. If you look at two parallel lines, they have the same exact slant, right? So they have the same rise over run. So it turns out parallel lines have the same slope. Same slope, kind of neat. So if I gave you two equations, let's say I gave you y equals 3x plus 1 and y equals 3x minus 4, right? If I gave you two separate equations of lines, if we wanted to graph these would be two different equations. But before we graph them, we can tell that these two lines are parallel because their slopes are the exact same, right? I mean, we can graph them. It's not a big deal. Just to kind of see it. So, let's see right there. The first line, my y-intercept is 1. Put it there. And then my slope is 3. Now remember, we're going to think of it as 3 over 1. So I'm going to rise 3, 1, 2, 3, and then I'm going to run 1. So it puts me about right there. Okay. The second one, so that's the first, we'll label that 1. Why did I label it 2 over here? It's 1. So the second one, though, has a y-intercept of -4. So I'm going to go down here. 1, 2, 3, 4. Crosses right there, but it has the same slope. 3 over 1, right? So I'm going to go up 3, 1, 2, 3, and then over 1. And notice now this isn't perfect, again, because I'm just drawing this by hand. But there's my second line. These two lines are parallel, right? They'll never touch. If I graph them properly, they would never touch. But we don't have to graph this to see that. We can see that both of their slopes here in this y equals mx plus b form are the exact same. So therefore, they are parallel, okay? Okay, so what about perpendicular lines? Perpendicular lines are a little different. Let's write down here. Okay. Perpendicular. Perpendicular lines, they do cross, right? And they cross in a very special way. They cross at a 90-degree angle, okay? So if I wanted to graph two perpendicular lines, let's use a different color. Actually, the x and the y-axis are good examples of perpendicular lines. But let's say I had some line out here on this plane, this two-dimensional plane, and I wanted to graph a perpendicular line to it. I'm going to try to get it as close to 90 degrees as I can. How that was close. We'll just put the little 90-degree label there. Okay, so it's got to cross at a 90-degree angle. And notice one of these is going to be positive because it's going to be going up and to the right. Well, the other one has to be negative, and vice versa. Okay, so with perpendicular lines, it's a little different. The slopes do have a relationship, but it turns out they're opposite reciprocals. So I'm going to write that down. Opposite reciprocal slope. I might be spelling reciprocal wrong. That might be an A. Reciprocal. Oh, man. Okay, so let's see what I'm talking about here. What does opposite reciprocal mean? So if I tell you that a slope of a line is, let's say, 2/3, okay? Oh yeah, I didn't tell you that the short. You don't have to write. You don't have to write the perpendicular every time. For shorthand notation, you can use an upside down T for perpendicular, and you can use just what looks like two parallel lines for parallel. So if I wanted the perpendicular slope, you could say this instead of having to write out perpendicular. So the perpendicular slope for this one, for 2/3, now it's opposite reciprocal. So what we're going to do is we're going to flip it and make it negative. So -3/2. That would be the opposite reciprocal slope. Okay, opposite reciprocal slope. So you take the fraction, you flip it, and change the sign. So we're going to do a little exercise here on how to find opposite reciprocal slopes. So I'm going to make a little grid. We're going to have the slope, and we're going to have the opposite reciprocal slope. Okay, we're going to have the perpendicular slope. So let's say we had -4/5. Well, you do the opposite reciprocal. We got to change the sign. So remember, if the slope's negative, the perpendicular slope then is going to be positive. So it's going to change it to a positive, and you flip it. So it's going to be +5/4, right? +5/4. Okay. So I'm going to give you a few of these, and I want you to fill them in without me doing anything. Okay. You just fill these in. It'll be a little exercise. So let's say we had a slope of 3. Well, fill that one in. Let's say I had a slope of -1/2. And then let's say I had a slope of 0. Okay, try those. I'll give you just a minute. Fill them in. See what you think. Okay. Well, 3. Now you got to think of this as 3/1, right? Think of it as a fraction. We flip it, so this is going to wind up being -1/3, right? And then -1/2, you flip it, it becomes 2, right? But then we change it from negative to positive. So this one is just 2. 0, though, is a little different, right? Huh. 0. What do you guys think it is? Put it in the chat. I'll see if you guys are actually here paying attention. What do you think the perpendicular slope is to 0? It's okay if you get it wrong. 0. Okay. Yeah. 0. Okay. Zero. We're just doing the Democratic 0 here. Now, wait a minute. Hold on. I told you guys earlier. Actually, let's go back to the last page. If they had the same slope, they were parallel, right? So it can't be 0. 0, I mean, that would mean it was the same slope, which means it's parallel. You can't be parallel and perpendicular, okay? So it can't be 0 because of that. Because of that, I'll tell you every time I do this, that's the number one answer. But I want you to think, well, 0/1 is 0 still, okay? But what happens when you get the reciprocal of that, Avery? What do you get? 1/0. Now, what's 1 divided by 0? No. 1 divided by 0 isn't 0. No, it's not. That's 1 divided by 1. What did we say anything divided by 0 is? Undefined. There we go. Is it chi? Is that how you pronounce it? Chi. Am I right? Yeah, key. Okay, thanks. Key. Perfect. So yes, undefined is exactly it. Key wins the brownie points for today. Okay. So think about this. The logic behind it is, if you want to think of it as, hey, 0 is just 0/1. Well, when you flip it, that becomes 1/0. Now you're supposed to make it negative as well. Negative doesn't matter. So -1/0, but anything divided by 0 is undefined. Now remember, so let's try it like that. Remember what kind of line has a slope of 0? This was a horizontal line, right? This was a horizontal line. Remember, it was flat line, slope of 0. Undefined. Now, if we want to find its perpendicular, a horizontal line, the perpendicular to it is a vertical line, right? And we know vertical lines have undefined slopes. Okay, and especially if you're like, man, I don't have that memorized yet, that's understandable. You'll see it in the homework a lot today, a lot this evening. Okay, so I know I do that every year. That's exactly what happens. Everybody says 0, and that's why I want to bring it up, because it's going to pop up in the homework too. Okay, so excuse me. So let's say I'm going to do the example, or one of the examples right out of the book. And it's going to be, actually, hold on. I'll do one of the homework questions. It's going to give you 2 equations, and it's going to ask you if they're parallel perpendicular, or neither. And I did sort of one already, right? Over here, right? I gave you these two equations. And if I asked you these two equations, I said, hey, are these parallel, perpendicular, or neither? You say, hey, the slopes are the same. It's parallel, okay? So let's do one like that, but not as easy. It's not kind of given to you in a way. So let's say I gave you, let me steal one here. Let's do 58. Yeah, 58 says, this is on page 196, number 58, and it says negative 2x plus 3y equals 1, and 3x plus 2y equals 12. And I'm going to ask you, are these parallel, perpendicular, or neither? Okay, I'm using that shorthand notation. Parallel, perpendicular, or neither. Now, to do this, we're just going to solve for y on both of them, and then look at the slopes. That's it. Okay, solve for y on both of them, and then look at the slopes. So I'm going to take this first equation, and I'm going to solve for y. Okay, so negative 2x plus 3y equals 1. I'm going to add the 2x. 3y equals 2x plus 1, right? And then I'm going to divide everything by 3. And I wind up with y equals 2/3 x plus 1/3, right? Y equals 2/3 x plus 1/3. I know I kind of zoomed through that, but we did an example of that earlier, right? Now look, for this one, we know the slope is 2/3. We know the y-intercept's 1/3. Now for parallel, perpendicular, and neither, we don't need to worry about the y-intercept. That's not a big deal, okay? Okay, we need to find now the slope of our second equation. Where's our second one? There it is, okay? If it winds up being 2/3, boom, we know that it's just parallel. If it winds up being negative 3/2, or negative 3/2, right? We know it's perpendicular. So let's do this one. I'll do it over here. 2. So we've got 3x plus 2y equals 12. So I'm going to subtract the 3x over again. I remember the goal is to get y by itself. And then I'm going to divide everything by 2. And I wind up with y equals negative 3/2 x plus 6, right? That's a 12. It does not look like a 12. Negative 3/2 plus 6. So we found the we found the slope-intercept form of this equation. So remember, these are good examples of what we did towards the beginning of this lecture, right? We're finding the slope-intercept of these two equations. And check this out. The slope here is negative 3/2. The slope here is 2/3. They are opposite reciprocals of each other, right? So it turns out that these two equations are perpendicular, okay? They're perpendicular, kind of cool, okay? Kind of neat. You'll see that in the homework. It's pretty cool. Okay. Sure. Kind of hit all this stuff. Yes. Good. Okay, let's do another one like that, but they give it to you a little differently. This is number 66 in the homework. Okay. Well, no, let's do 68. Number 68. Okay. This is on page 197. So there's all in that same 3.2 section. It says, look, line 1 goes through negative 410 and 2, -3. Okay, line 1 goes through negative 410 and 2, -3. Line 2 goes through negative 3,8 and 2, -5. Okay, so line 2 goes through negative 3,8 and 2, -5. And again, the question's the same. Determine whether these two lines are parallel. Parallel looks like that. Parallel, perpendicular, or neither. Okay, parallel, perpendicular, or neither. But now instead of the equation, it gives us two coordinates. So this turns out to be a really good example of finding slope, right? We just need to find the slope of this first line find the slope of the second line and see if they match for parallel, see if they're opposite reciprocals for perpendicular, or just to see if they're neither, right? If they're just two random numbers floating around there. Okay, so let's look at line 1 first. I'll use the 1 symbol right here. Okay, let's look at line 1 first, and we're going to find the slope. I'll do m sub 1 just to notate that this is from the first line. Okay, that's just a notation thing. Now remember, I'm going to call this x1, y1, x2, y2. So I'm going to have -3 minus 10. Remember, it was always subtraction. And then 2 minus a -4. So -3 minus 10, that's like -13, right? And then 2 minus a -4, well, that's 2 plus 4. So that winds up being 6, okay? That winds up being 6. Yep, -310, yep. So we get -13. So now look, if it's the same thing, if it's -13 over 6, boom, we know it's parallel. If it's 6 over 13 positive, it's perpendicular. If it's just something else, it's neither. Okay, so let's look at the second one. We'll do m sub 2 here. And again, I'm going to label, kind of keep these same labels just vertically. So we wind up with -5 minus 8 over 2 minus a -3, right? 2 minus a -3. Well, -5 minus 8, that's -13. Okay, we got that part. But 2 minus a -3, that's 2 plus 3. That's not 6. 2 plus 3 is 5, right? Oh, it was so close. Okay. Not -13 over 6, but -13 over 5. So this turns out to be neither. If this was a 6, it'd be parallel, right? If this was -2 minus a -4, this would have been +6 down here, and it would have given us the same. It's not parallel, or it's not perpendicular, you're not flipping them. So this one just turns out to be neither. Okay, great. Good. Okay, cool. Now, so I'm going to give you homework from each section. And then you're more than welcome to stick around here and ask questions, but let me give you this homework first. So on page 194, it actually starts on page 194, goes 194 to 197. Numbers 1, this is 3.2. 1 through 60. Okay. Oh man, that's a good one. Okay, this doesn't take long. Once you get the knack of it, it really kind of goes quick. So I know it's going to feel like I'm giving you a lot of homework, but a lot of these are just, pulling out, oh, hey, that's the slope. Hey, that's the y-intercept. It really isn't that bad. So 1 through 67, and then okay, hold on. And then I want you to jump over and do 70. Hold on. Let's do 75 through 91. Now these are all odd. Okay, these are all odd. I'll give you the odd ones. And then on page 203, which now this is 3.3, just 1 through 27 odd. 1 through 27 odd. Now, if you can't get through all of this, if you can't set aside enough time to get through all this, I want you to at least look at it, okay? Or do every other odd. That would be fine as well, okay? I know this is a longer section. It's more homework than I would typically give because it's